Hi, today's lesson is on absolute value or modulus of a number and linear expression. So, the absolute value of a number x denoted by modulus of x or simply mod x. What does it imply? If x greater than equals to 0, then this mod x equals to x. If x less than 0, then this mod x equals to minus x. This means that absolute value or modulus of any number is always positive. What we are taking like this way, like mod 4 equals to 4 as 4 greater than 0, but modulus of minus 2 is also 2 as it is taken as negative of minus 2. Now take an example like that way. Suppose a set is given by mod of x equals to 5. What does it imply? That mod x equals to x when x greater than equals to 0. Therefore, mod x equals to putting the value that mod 5 equals to 5. And yes, x is greater than equals to 0. Similarly, mod x equals to minus x when x less than 0. Therefore, it is taking this value that minus 5, and yes, minus 5 is less than 0. Therefore, mod of x equals to 5, it implies x equals to plus or minus 5. Now, use the number line to represent this in the subset of like that way. We can consider it now that, okay, I am changing the color of ink is to black. Yeah, fine. So now say I am taking a subset like mod x less than equals to 5. How to represent this set on a real number line? So just to represent it on a number line, we need a horizontal line. Take here the origin O, that is 0, and then I am just marking it so that I can say that plus 5 or minus 5, like that way. This right hand side is plus 5, say this is minus 5, sorry. This is minus 5. Now, we need to match the condition like, so whenever x will take a value, it should be less than positive 5. Now, here when it is x is taking value 2, yes, it is less than 5. When x greater than equals to 0, it is okay, it is less than 5. But what's about this side? That x is minus 5 when x less than 0. But less than equals means what? Now, the modulus of minus 5.5, if we take the mod value of minus 5.5, the modulus always take the positive value, so it will come as 5.5. So, this doesn't satisfy our given condition that x less than equals to 5. But if we take a point over here and say it is minus 3, then modulus of this minus 3 will always give a positive 3, and yes, that is less than 5. So it means we are having a subset that lies minus 5 to plus 5. Take one more example, like that way we can get a little more clear concept about it. Say x, modulus of x greater than 1. So we already know when x is greater than equal to 0, then x value would be plus 1, and when it is less than 0, the value of x would be minus 1. So take that way on number line. It's a line and we call it, this is our origin O. So this is 0. Now I am taking it here as plus 1 and here it is minus 1. So this is plus 1, this is minus 1. Okay. Now let's see, as it is greater than 1, so it doesn't touch this point. So what I am doing, I am taking a hollow circle over here. Now x greater than 1. So x is greater than 1 is expands towards positive infinity. Now here is x less than 1. What is happening here? We just put this condition that if x is say minus half over here, the mod is half, so it doesn't satisfy the condition x greater than 1. So x cannot take this minus half value. So here again it is something like that way, and if we take just a check up that if it is minus 3 by 2, then mod of this value is again positive 3 by 2. So that is satisfy our condition that x greater than 1. So x also extended from here towards the negative infinity. So how we can express this two thing in set form? Suppose for this one, the first one, yes, in set norm we can write it that x, it is lying in between, you see, minus 5, and as it is touching, so I am giving the equal sign as per the condition. And in interval notation, it should be a solid third bracket, a closed third bracket, yes, this way. And for this thing, we can see, we can have to make a union kind of thing of two sets to represent this. Like in set notation, we can write x minus 1 greater than x greater than plus 1. And interval notation, see, as it is infinity, it cannot touch, so open third bracket, and minus 1 again open third bracket, union the same manner, or we can use this first bracket as well, 1 infinity, positive infinity. Now the linear equation. The linear equation, actually it is considering a single variable, say suppose x. How we can express it? A linear equation in the variable x takes on the form ax plus b equals to c, whereas ax plus b equals to c. The linear equation of x, a single variable. So, simply rearranging it, we get that x equals to c minus b by a. So, take an example. Suppose we can write a linear equation, say, number 1, 5 into 3x minus 2 equals to 15. So, what we can do, we can cancelling out the common factor, and it is 3. Therefore, 3x equals to 3 plus 2, rearranging it. So, x equals to 5 by 3. So, this is my solution of the linear equation. Now, simply check if you are considering the absolute value, then how it would be. Now, when we are doing the linear equation involving absolute values, we can write the same linear equation in form of ax plus b equals to c. Now, simply recall what we have learned in that absolute value. This ax plus b, ax plus b in modulus is simply ax plus b when this ax plus b greater than equals to 0. This gives rise that x greater than equals to minus b by a. Simply rearranging this. And again ax plus b equals to minus of ax plus b when ax plus b less than 0, it means x less than minus b by a. Therefore, this can be written as we are having the two situation now, that ax plus b equals to c, and similar way we can get this first solution as x equals to c minus b by a when this situation is true, that x greater than equals to minus b by a. And then x equals to minus c plus b by a when x less than minus b by a. Just to understand this thing, let's take up an example like mod of x minus 3 equals to x. What it gives rise? It gives rise to situations. So, I am writing it like that way, x minus 3 equals to, the first situation is x, it becomes x minus 3 if, or you can say also when, x minus 3 greater than equals to 0, arranging it I am getting x greater than equals to 3. Again it is x minus 3 modulus is minus x minus 3 if x minus 3 less than 0 or x less than 3. Now, to find the solution, I am considering the case 1. Case 1 is what? Where x greater than equals to 3. Just putting this x minus 3 in my this equation equals to x. So that gives x nullifying minus 3 equals to 0 and has no solution. So we don't have any solution when x greater than equals to 3. Now considering the case 2. Considering the case 2, we can see that I am taking this one and putting it in the same equation. Minus x, okay, I am taking it in bracket first, equals to x when x less than 3. Okay, so this gives minus x minus 3 equals to x. Rearranging, I am getting minus 2x equals to this is plus, so it is minus 3. Now nullifying this minus, x equals to 3 by 2. It means 1.5. Now this solution actually satisfies this condition. So for this equation 1, we are having one solution, that is x equals to 3 by 2, considering x less than 3. Now check some further examples of one from linear equation and one we also do for linear equation involving absolute values. So number 1 equation, I am taking it that 5 by x plus 1 plus 2 equals to 1 by x plus 1. Now solving this, we are seeing that both are having same denominator. So we are rearranging it like that way. So I am rearranging it or writing it 5x plus 1 minus 1 by x plus 1, leaving it in bracket, equals to minus 2. Or as denominator is same, we can do this 5 minus 1 equals to minus 2, or minus 1. So it is 4 by x plus 1 equals to minus 2. Now nullifying the common factor, this is 1 and this thing, by cross multiplication I am getting 2 equals to minus x minus 1. Rearranging it, I am getting x equals to minus 3. So this is my solution of this equation. Now take one more example of linear equation involving absolute values. Suppose x plus 1 modulus plus x minus 1 mod equals to 3. Now see, there is 2 modulus, so we need to consider these two separately. These two separately, like now x plus 1 modulus, I am writing it in this way, that it is x plus 1 if x plus 1 itself greater than equals to 0 or x greater than equals to minus 1. Again it is minus x minus 1, multiplying that minus sign with the both, if this x plus 1 itself less than 0 or x less than minus 1. Then I am considering the second term, modulus of x minus 1. In the similar manner, it is x minus 1 itself if x minus 1 greater than equals to 0 or x greater than equals to plus 1. Or I am multiplying this minus the negative value, minus x plus 1 if this original value x minus 1 less than 0 or x less than 1. Now for this case 1, I'll take this first these two conditions. The first is I am taking that x plus 1 plus x minus 1 equals to 3, where both this condition will satisfy. Now let's see. I am getting it 2x and nullifying this thing 3. So I am getting x equals to 3 by 2. Now see, when x greater than equals to minus 1 or x greater than equals to 1, yes, 3 by 2 lies a point where these two conditions are satisfying. So yes, 3 by 2 is a solution for my given equation. Now see the case 2. Case 2 is my these two case. Considering them, I am writing it is minus x minus 1 plus, and that is multiplying, so minus x plus 1 equals to 3. So what I am getting, again this is nullifying, it is minus 2x equals to 3 or x equals to minus 3 by 2, when I am seeing this two condition, whether they are matching it, when x less than minus 1 and x less than 1. See, both this condition, this value of x minus 3 by 2 matching this condition. Yes, minus 3 by 2 is less than 1. Yes, minus 3 by 2 is also less than minus 1. So for this equation we have two solution of x, and x equals to plus minus 3 by 2. I am hopeful that I clear out all the points and you also understand all these things. If you have any problem in understanding, do leave a comment. I will try to address your problem as soon as possible. Thank you very much for watching the video.